Today I'm here to introduce you Cartesi Rollups. I'm going to give you a quick overview of Cartesi, how it came to be, and a little bit of how the Rollups itself works, what is the basic infrastructure that makes it possible. And I'm going to show you a few projects that have been built using Cartesi in other hackathons, such as this one. So, a sneak peek, this is a Python code. It's kind of like a script at this point, but it's basically a Cartesi dApp already. This dApp is an Echo smart contract, so it will be the equivalent of having a Solidity contract that whatever it receives, it replies it back as an Ethereum event. But here you can see that we're importing Python libraries, we are using HTTP requests, and how the fuck is that possible, right? So Cartesi. Here, I feel like this kind of public, we don't need to explain the trilemma again and what AVM brought to us. Basically, Ethereum brought some very interesting properties, but it came at a cost of scalability. And EVM itself, it's a really good machine to embody the necessities of the constraints of a blockchain, but at the same time, it limits our content capability. So meaning that even if you, by some magical reason, manage to get much more output from the EVM, you're still constrained by the format of the machine itself. So the idea is, what if we can have complex computations and blockchain security guarantees and still add great tooling to it? So basically, what if we can have Web2, the Web2 ecosystem going back towards the blockchain? So the basis for that is two pieces. First, Cartesi is application specific, meaning that you can deploy this on top of any other network or on top of any other rollup. It can be a zero-knowledge rollup, optimistic rollup, as long as EVM compatible. This could be deployed on top. So it's technically is a layer N solution. And the second one is the RISCV deterministic machine. Because of this platform processor, which is an open source competitor to some extent to Intel AMD, you can have an OS, so meaning you can have Linux back. And in this way, basically you're enabling the ability of having JavaScript, Python, SQLite databases, any of the other framework and tooling that we're used to support our applications. Because the Cartesi machine itself is deterministic, meaning you can do interactive fraud proofs back on the base layer that you chose to deploy. So to be more visual, this is what it looks like to be coding for the EVM ecosystem right now. You have a very good plier and sets of pliers, but that's it, right? If you need to nail, you cannot really do it that properly. And Cartesi is trying to bring back all the tooling that we used to have. So, and that really looks like this. Your Cartesi dApp, at the end of the day, is a Docker build. You basically do your recipe, your Docker file, you build a Docker image, bundle that to the Cartesi node. Now you've created a node that is specific to your dApp, meaning you now have your application-specific rollup. And that's what it feels. You can have your favorite language. You can use complex libraries to do things that we just take for granted, like, for instance, logarithm. You can have all these other frameworks, even that one-star repo that sometimes just comes in so handy. You cannot really use that with Solidity, really, right? So, and here is like an attempt to compare what it means to code in such platform when compared to EVM. So being very generous to the Ethereum network right now, you can have a maximum of 30 million gas per block. And the less expensive, useful opcode would be add or subtraction, which costs free gas. So we're looking at 10 million instructions per block. That's being very generous, right? And to put Linux, and we know this because we have all the inspections here, it's kind of small to read. It's about 36 million instruction cycles. So that's just Linux booting and being ready to do whatever you program it to. And just to be fair then, we limited the Cartesi machine to 13 seconds execution, which would be the average block time, right? And in 13 seconds on a laptop such as this one, you can have 3.7 billion instructions being executed. So the power that it brings back is very huge, and it's even difficult to grasp. So here's an image that helps you with that. That little black box over there is the 10 million instructions of EVM compared to the 3.7 billion ones of a 13-second execution on Cartesi. So how is the rollups itself, right? An overall architecture here for people who are not familiarized, things don't change too much. I realize now the white contracts didn't work too much, but basically you're gonna have, let me see if my pointer here works. Yeah, you still have your connection with the JSON RPC here because it's still a rollup. So to a certain extent, you're committing your information. You're committing your information to the chain as for the input as for the rollup, so you don't have the impasse of the data availability. And then the node that you build here, represented as Cartesi Rollups framework, will be digesting this information. And that might be you as a validator, that might be the user as well, trying to verify whether or not you're doing something wrong. And as it digests, it can create new outputs that go back to the Ethereum chain. So it might be, for instance, just the Merkle root for the state the state of the machine, or might be like new transactions that will do like withdrawals, for instance. And inside, I chose to make a little bit of a highlight of this HTTP rollout server here. So this is still a machine. Linux doesn't know what the fuck it is doing inside there, right? So to deal with the drives, to deal with the low-level communication of halting the machine, getting a new drive, inputting the information that came in this new digest from the chain, then halting the machine again, getting this binary information of the output drive, interpreting it and putting it as an output to the Ethereum chain, for instance, will be too much. So we created a abstraction there. We created this API, REST API. It's 4 endpoints. The documentation you can read in 30 seconds. And just by hitting these endpoints, you can have an abstraction of how to input information and output information into the chain. So then all you need to do as a developer is really choose your language, communicate through this API, and there you go. You can have a smart contract in the shape that you like. It can even be like a microservice. I don't know what for, but if you choose to do so, you could. So talk is cheap. Let's go back to that code. Not trying to explain every little bitty nitty-gritty detail here, but to this side, to the left side, we created this little helper tool. It's similar to what Forge have been trying to do, so you can sign transactions easily and call contracts. For now, we just created this custom one, and with this, you can send payloads as input or as Ethereum calls to a certain extent, and you can read all the outputs. Here, notices. We call them notices because just one singular difference from the Ethereum events. Ethereum events are not provable. If I give you a payload for an Ethereum event, it doesn't mean anything without the hash of the transaction, and really, it only means something if you go through the chain and verify that it actually creates the output, right? And notice can have Merkle proof attached to it. So as long as you have the state, the root tree of the Merkle, the Merkleization of the machine being committed to the chain, from that Merkle root, you can create the Merkle proof for anything the machine creates, such as the notice. So you can prove notices on chain. And here is just listing the new notices created at this epoch. And here's the thing. So this program here should do the echo thing I was talking about, right? So from there, like I was saying before, you import requests because you're gonna be doing REST requests. You get it from the environment variables. We already put it there for easy for you. And we have 2 top-level handlers here. You can create as many endpoints as you wish, but these 2 top levels here are obligatory. Why? Because just like Ethereum EVM, there is 2 states of how to run the machine. There's one that will change the state of the blockchain, and there's one where you're just trying to digest information from it. So it's ephemeral. So if you got inspect state here as your request type, it means that no matter how much change you do to the machine, it always gonna all of it is gonna be throw away, just like in a hypervisor and VMs. And if you got an advanced state, you really should be careful with whatever you're doing, because however you stop the machine there, it's gonna be the state that the machine will be for the next transaction. So this is still code, right? If you throw and you lose your process, there is no way for you to restart this. It's kind of like self-destruction, a contract, or putting in a bad state, just like the Parity wallet hack. And the only last thing I think it's worth mentioning more specifically is that every time you get this new request, you should reply back what was the final state of the whole processing. So you should go back and say status accept. If you say status reject or you don't reply for a long time, the hypervisor, quote unquote hypervisor, will understand that something went wrong, and it will tag that transaction as a reverse, so to speak, and it will revert back the machine. So here, in this case, we would get the information here. We would unroll the JSON file, the JSON request. We get to the advanced state top handler. We didn't register any other handler, just this global one. Here you see, like, I'm getting the payload. I'm just creating a new notice with the same payload because it's supposed to just be an echo. And finally, I just go to /notice with that payload. I'm creating it. You can call it as many times as you wish. Return the accept thing I was talking about before, and you close your loop. It's an infinite loop program in this case. So you're always waiting here at finish. So finish is a special endpoint that will halt the machine. You don't need to do anything else especially. Because this machine is deterministic and single-threaded, you don't need to be managing these scenarios, these edge case scenarios. So the idea here is really like you can further decentralize your dApps, because sometimes the dApps are not so decentralized because they lack CPU power or they lack the expression capability of putting there all the rule sets, all the necessary corner cases, handlings, and everything. You can, of course, then express more complex logic, and this extra processing power lets you leverage the traditional stacks that we had before. And it also, as a new project, you should be thinking sometimes that the talent pool for Web3 people is really short. So maybe you can get started with 2-3 people, but as your project grows, you need to hire more people, and it's way easier to tap into the Web2 talent pool. So it's easier for them to be onboarded with such technology. So let's see the epochs. So I collected 2 examples here from previous hackathons and attempts of building things with Cartesi. And one of them was just at ETHGlobal Lisbon, just before. And she was actually a track winner, track finalist. And what she did was to put an LLM inside a Cartesi machine so she could have verifiability on the outputs produced by the LLM. Her concern was kids very soon will be using ChatGPT and likewise tools to be learning about things, just like Google. And at some point, they might be questioning something like, oh, okay, I'm going to run a marathon. What should I be drinking to maintain myself hydrated, right? And then she wants to avoid a scenario where it goes like, oh, you should drink Coca-Cola or you shouldn't drink beer. And not having the proof that this is happening and not having where to start to backtrack and see where did, in this case, Coca-Cola influenced the LLM model to be producing such a propaganda instead of its responses. So she created this, sandboxed on-chain version of LLMs that can have the verifiability. The second one is a curious one. So this guy, he wanted to intervene in the situation of clocking in, clocking out into government offices. So it happens in many places, but especially in Brazil. these guys, they find ways around the system to not be there, take longer vacations or be late every day, and still show on the system that they are there by using silicon fingers or by bribing the guy that's supposed to ensure that nothing's going on wrong with the machine. So what he did is two-folded. And here, what I like about this example is just what he could use, not exactly the example. He used OpenCV to do the biometrics, so he can identify the digital, the fingerprint of people. And he used a machine learning model to avoid the spoofing of the information. So he can detect whether or not there was silicon fingers used or reuse of images and things like that. And that was all running on chain. Actually off chain, but being proved on chain. Here we have this community website, rolluplab.io. There's several examples using Cartesi there. It might trigger your curiosity. There's things from DAOs to games. It's really a cool resource. And at ETHGlobal here, we are tracked as well. So we have up to $10,000 of prize pool. And I hope I can see you there. I'm going to be at the booth. Me and my friends, I'm going to give you all the support that you need. One final announcement is that we are launching on mainnet next month, probably, with a honeypot dApp. So the foundation is supporting this initiative where they are going to be putting money inside this dApp just as a target for hackers and other developers to try to steal it, as a showcase of the security and the verifiability of the rollup framework. I thank you for being here. This has been nice. It's always really good to be at ETHGlobal talking to interesting people. But before I go, I have one more thing. So few months ago, this guy went to Twitter to say, if Ethereum is the world computer, why haven't we seen the Doom running on it? Like, how so, right? And one of our collaborators, core developer, Eduardo, he actually took it on. And he put Doom to run on the Cartesi machine. If you want to check it out, we are running actually a leaderboard downstairs at our booth. You can play there. There's full apps and stuff. Thank you again, guys. Does anybody have questions?
I have one question. First of all, my first question will be, how do you handle upgradability?
Upgradability?
Yeah, in a rollup. I mean, in a Cartesi rollup. Once you deploy the first smart contract, the dApp.
Yes, yes.
How do you upgrade? What do you need to upgrade? No,
for sure. I feel like we are kind of like in 2016, 2017 Ethereum situation, how we deal with upgradability for Cartesi as well. But we at least one layer out in abstraction, so we have more recourse. So one of the things that we already support is when you deploy your dApp, you can enable it to be upgradable or not on the smart contracts deployed on the chain, so like Ethereum, for instance. And there, it can really just point towards a new Cartesi machine. So really like changing everything, just like a proxy would. It's still a question like what happens to the data? Are you upgrading from another one that you messed with? Like, did you open like the Cartesi machine to stay with the data, change the code and bundle it and release it again? Or it's really open because with this is so many possibilities. It's still up for debate, like what is the best practice of how to be more clear, transparent with the community as you do it. But you really can do a lot. Like, there's no singular answer for now.
And how does it? Yeah.
Will you be here during the hackathon so that we can ask you question about how to deploy this?
Yeah. Besides me, there are two other technical people here.
Congratulations on the talk.
Thank you.
Are you recording the high scores of the Doom on chain?
No, not so far. I mean, indirectly because of the pull-ups. But the leaderboard itself is not like a singular contract with everything there. No, not really. It was more like a demo for ETHGlobal.
Should have a bounty for that.
Sorry?
Should have a bounty for that.
Oh, true. We should.
Negotiate a good price and get it done. Any more questions?
Hello. Quick thing. What wallets are supported, or how does the wallet interaction flow look?
Sorry, I didn't hear everything.
Yeah, the wallets that you support, and what does the wallet interaction flow look? Because this is very sort of tooling around building the sort of payloads and smart contracts. Actually, how do you then integrate a front end to something like this, for example?
Oh, okay. So far, it's really like just like Ethereum. All the inputs go through the chain. So that much doesn't change. So technically, everything is very customized. There is no like hard hat or ethers for Cartesi yet. So in that sense, there is like the graphical and REST API connecting directly to the node, so you can have easier access to the information, just like you would for Ethereum node. And that could feed in a front, and then like all the inputs, they are just signed transactions to Ethereum, so there is no change there.
Is like the Cartesian machine like locked? For example, in the example you showed that it is requesting data from an API,
Yeah.
right? So if I imagine, okay, I can call any API, I would be able to change the state inside the machine, or is it like boxed and you can only call?
No, that API is just an abstraction to the communication with the chain. That's the only API you can call that will be talking to the outside. Everything else is sandboxed. Even the API itself is running inside that machine. It's just really an abstraction.
Okay, thank you.
Please give another round of applause for Gabriel.
Thank you.